Okay, now that we've completed the table, we are going to use our table to graph this function. So notice our speed starts at 45 miles per hour. So on my x-axis, I'm going to label the first tick mark at 45 and continue to go up by 5. I think I may skip every other space just for a little bit more room. So for example, I'll skip the next tick mark and then I'll go to 55. Skip one and then 65 and so on. Okay, now for my y-axis, I go from about, my lowest currently is 3.33 hours, and my highest is almost 7 hours. So I'm just going to go up by 1 hour, but again, I think I'm going to spread this out a little bit more. So my first tick mark would start at 0, and then I'm going to skip a space and go up to 1, skip a space 2, all the way up to 7. And now I'm going to plot my points. So at 45 miles per hour, the time was 6.67 hours. So this doesn't need to be perfect, but you just want to plot each of the following points. Please go ahead and pause the video and continue to plot your points. Okay, so we get a better picture. I think I'm going to add 2 more x values. So I'm going to add 95. So when you do 300 divided by 95, we get 3.16. And then I will add this to my graph. And then I'm also going to add 100. So 300 divided by 100 gives us 3 hours. So you might start to notice that our graph is not decreasing quite as quickly as it started off. It's almost kind of starting to level out a little bit. And we'll talk about that more throughout the week. So now for my questions. The first question asks, an express bus makes the trip at an average speed of 70 miles per hour. How long does it take to make the trip in hours? So we know the speed is 70 miles per hour, and we're trying to figure out how long or how many hours it takes. So if I write this, setting up my equation, so I have the time for a speed of 70 miles per hour. So I would take 300, the distance, divided by my speed. And this is something that you could either use your calculator or you could also use Desmos. So here, if I go back to Desmos, I would probably want to just use the scientific calculator. So I would type in 300 divided by 70. So we get 4.29. So that tells me it will take 4.29 hours. The next question says a train makes the trip in 2.75 hours, and we want to calculate the average speed. Explain the answer in a complete sentence. So this time they're telling us the time. So I'm going to put that on the left-hand side in for t. And I'm going to set this equal to our distance of 300 divided by x. So we're trying to solve for that speed. Just like you did yesterday, I could set up a proportion and cross multiply. So I'm going to write 2.75 over 1 to make it a fraction. And then I cross multiply. So I get 2.75 times x equals 300. Divide both sides by 2.75. So this would be an example again where you might want to use that graphing calculator or that scientific calculator. So if I do 300 divided by 2.75, we get 109.09. This time I was calculating the speed, so it would be miles per hour. Please take a minute, pause your video, and try number 6. For number 6, you should have gotten 85.71 miles per hour. Now, as we look at the backside, So number 7 says, what is the domain of this function? And I'm going to try and simplify this a little bit. So one thing I want you to know is domain is our x-axis. And we said that the x-axis was going to be speed. Well, when we think about domain, we want to think about any restrictions. So for example, I know that when I'm driving a car, my speed cannot be negative, and I can't have a speed of 0, because in that case, I wouldn't be going anywhere. So in this case, x has to be greater than 0. As far as our range goes, so our range is the y variable, and in this example, that is time. So again, I want to think about any restrictions on my range. So since my time also cannot be negative and cannot be equal to 0, that means my range would be y is greater than 0. Now for our average rate of change. So we've talked about this quite a bit this semester so far, but just a reminder, average rate of change is a funny way of saying slope. So I'm looking to calculate y2 minus y1 over x2 minus x1. So I need my 2 points first. Well, I want the average rate of change between 70 and 80 miles per hour. So if I look on my table from the previous slide, my x-coordinate is going to be the speed, my y-coordinate is the time. So for 70 miles per hour, I want to check what was the time. Looking on the table before, it looks like it was 4.29. I'm going to do the same thing for 80 miles per hour. So for 80 miles per hour, I look on the previous page for the time that it took, and that was 3.75 hours. Now I'm going to calculate my rate of change. So I take 3.75 minus 4.29 and divide by 80 minus 70. So I get negative 0.54 divided by 10, which gives me negative 0.054. So what does this tell me? This tells me from 70 to 80 miles per hour, the time it takes to travel is decreasing approximately 0.054 hours for each mile per hour faster you drive. So I know that the average rate of change is decreasing because when I calculated it, I got a negative number. Now looking at number 10. So 10a says, how long will the trip take if your car travels 0 miles per hour? Well, we kind of discussed a little bit earlier that if my car is traveling 0 miles per hour, then my car's not moving anywhere. So I can't tell how long it's going to take. So I'm just going to put not possible. Car would not be moving. What does this mean about the graph? So this means our graph actually has a vertical asymptote. A vertical asymptote is an imaginary line that your graph gets really close to but never actually touches. So for example, if I look back on the graph on Desmos, I can see that there's kind of this imaginary line between those two curves on my graph right when x equals 0. We're going to discuss that a lot the week after spring break. Now, the last question says, how fast would your car need to travel to make the trip in 0 hours? Well, hopefully you can kind of see that this isn't possible as well. No matter what speed my car is traveling at, I cannot make the trip in 0 hours. So this also means that we have a horizontal asymptote. So for instance, if I go back to that graph again, we can kind of see when y equals 0, it kind of levels out here. We have another imaginary line in between those two curves. And when we talk about graphing after spring break, we're going to focus a lot on those vertical and horizontal asymptotes. Okay, after watching this video, please complete pages 4 and 5 in your note packet.